Hello guys, I am Aldrin and I am here to discuss and explain diagrams on the operating system structures. And now let's get started with the first diagram. In this diagram, it shows you a view of operating services. It is also divided into three major parts: the user and other system programs, the operating system, and the hardware. Under the operating system, we have the user interfaces, the system calls, and the services. In the user interfaces, we have GUI, batch, and command line. And now I'm gonna show you example images of what GUI, batch, and command line looks like. So here is a graphical user interface of a Windows 10. And the other examples are Mac OS X, Linux, and Ubuntu. Next is a batch, which uses the command prompt of an operating system. Next to a batch interface is a command line interface. Next is the command line interface. In the command line interface, we have the Cisco command line interface. It has the data of connections of a computer and networks. So now we proceed to the services of an operating system. So first, we have the program execution. A program execution is when the system must be able to load a program into memory and to run that program and execution either normally or abnormally, indicating an error. Next operation or service is the input and output operations. A running program may require an input or an output, which may involve a file or an input-output device. Next to input-output operations is the file systems. The file system is of a particular interest. Programs need to read and write files and directories, create and delete them, search them, list file information, and permission management. An example of file manipulation is through using File Explorer in Windows. So next to file systems is communications. Processes may exchange information on the same computer or between computers over a network OS. Communications may be via shared memory or through message passing, wherein packets are moved by the operating system. Next is resource allocation. Resource allocation is when multiple users or multiple jobs running concurrently, resources must be allocated to each of them. Many types of resources include CPU cycles, main memory, file storage, and input and output devices. One good example here is the task manager. Next to resource allocation is accounting. Accounting lets you to keep track of which users use how much and what kinds of computer resources. Apart from that, we have the error detection service. OS needs to be constantly aware of possible errors. Errors may occur in the CPU and memory hardware, in input-output devices, and in a user program. So, one programmer should know much more about the debugging facilities in order to have good services in error detection. Next to it is the protection and security. Here, the owners of information stored in a multi-user or network computer system may want to control use of that information. Concurrent processes should not interfere with each other. So that were the services of an operating system. Well, now let's proceed to the system calls. System calls tend to be the bridge between the system programs or the user application programs and the hardware of the computer. System calls are usually written in a higher level language such as C or C++. So now to explain further about system calls, let us proceed to the next figure on how system call works. So here you can see an API system call OS relationship. So let's define first what is an API, a system call, and an OS relationship. So an API is application program interface. It is a set of routines, protocols, and tools for building software applications. An API specifies how software components should interact. Additionally, APIs are used when programming graphical user interface components. Next, we define system call. A system call in computing is a programmatic way in which a computer program requests a service from the kernel of the operating system it is executed on. So as I said a while ago, it also functions as the bridge from the user application to the hardware of the computer. So here we go back to the diagram. Here it shows how an open function is sent from user application to system call interface. Now the system call interface requests the service from the kernel mode. So here the system call interface maintains a table indexed according to these numbers here in kernel mode. And now you can see the implementation of the open function system call, which is now then the values is returned to the system call interface back to the user application to run the open function in the user mode. So that's how a system call works in bridging the function from the user mode to the kernel mode and back to the user mode to run the application. So that's how API, system call, and OS relationship works. Now that's all, and thank you. I hope you learned about my discussions.